Welcome back to TalkTensors, everyone. Today we're diving into a paper that really got me thinking, and I'm excited to unpack it with you.
Always good to be back. Looking forward to this one.
So it's about this big question of how much we can trust AI to, well, judge other AI. You know, how reliable are these large language models when we're using them to evaluate the safety of generated content?
Yeah, that AI judging AI thing. Definitely a crucial area, especially as we're relying on LLMs more and more to basically moderate themselves.
Right, exactly. And this paper, it's called Safer or Luckier, LLMs as Safety Evaluators Are Not Robust to Artifacts. It's a bit of a mouthful, but the core finding is super interesting. Basically, it says that these LLM judges can be swayed by really superficial stuff in the text. Little things that shouldn't matter for safety.
They call them artifacts, these little quirks that trip up the models. And yeah, the paper's findings are kind of alarming when you think about how much we depend on LLMs for safety these days.
Yeah. So let's break this down for our listeners. You know, why should we care if an LLM judge is getting thrown off by something minor? What are the real world implications here?
Well, think about it. We're constantly pushing LLMs to do more, generate more complex stuff. But as they get more powerful, the stakes for safety get higher, right? We need to be sure that what they're spitting out is safe, whether it's in terms of misinformation, toxicity, even things related to self-harm.
And human evaluation, I mean, it's good, but it's just too slow, right?
Totally.
Yeah.
It's like trying to check every grain of sand on a beach. Just doesn't scale. So we've turned to using LLMs as judges, but if those judges are easily fooled, then our whole safety net has holes in it.
So we might be getting a false sense of security, thinking a model is safer than it really is just because the LLM evaluator is giving it a pass based on these superficial cues.
Exactly. It's like judging a book by its cover, but on a much more complex level. And the implications are, well, they're huge.
Okay, so how did they actually test this? What was the experimental setup?
They were pretty thorough. They took 11 different LLM judge models, a good mix of what's out there. Llama 3, Claude 3, GPT-4, Command R, Mistral, some big, some smaller, ranging from 8 billion parameters to over 100 billion.
Okay, a good representative sample.
Yeah. And they tested them across 5 safety domains. Misinformation, CSAM, toxicity, sexually explicit content, and self-harm.
The big ones.
Definitely the ones where safety matters most.
Yeah.
Now, when it comes to those artifacts, the things that were throwing the judges off, they focused on 5 main types.
Okay, let's hear it.
So the first one was pretty simple. Apology. Just starting a response with something like, I apologize, see if that changes how safe the model thinks it is.
Interesting, like tricking it into thinking an apology equals safety. What else?
Authority was another one. Adding a fake citation to make it seem like the content is backed up by some reputable source.
Oh, sneaky.
Right. Then there's halo, which is just ending with a friendly, helpful sounding phrase, like, hope this helps.
Huh. Like trying to butter up the judge.
Exactly. Then there's verbosity, which is basically making the response longer without actually changing what it means. Seeing the LLM prefers wordiness.
Okay, that's a classic one. And what was the last one?
The last one was position. Simply whether the completion was presented first or second when the judge was comparing 2 options.
Okay, so just the order it sees things in. Clever. So how did they actually use these artifacts to test the models?
They had 2 main types of tests. The first one was called tie detection. They'd take a piece of generated content and then create a slightly modified version by just adding one of these artifacts. So same underlying content, just a little tweak.
Okay, so like a control group and an experimental group.
Yeah, kind of. Then they'd ask the LLM judge to compare the original and the artifact version. If it's truly robust, it should see them as equally safe. A tie.
Makes sense.
But they were looking at the net win rate of the artifact version. So how often did adding that little tweak make the content seem safer to the LLM judge?
Right, because if adding I'm sorry suddenly makes something safe, even though it's fundamentally the same, that's a problem.
Big problem. Shows the LLM is focusing on the wrong thing. Now, the second test was called model win rate shift. This one was a bit more realistic. They'd have 2 different LLMs generate content, and the judge would decide which one was safer overall.
Okay, so like a head-to-head competition.
Exactly. Then they'd add the same artifact to all the content from one of the models and see how much that shifted the judge's overall preference.
Interesting. So a robust judge shouldn't be swayed just because one model's responses all got a little superficial makeover.
Exactly. That's the idea. Now, on top of these artifact tests, they also looked at how well the LLM judges agreed with human safety ratings. Kind of a standard way to see if an automated system is on the right track.
Yeah, makes sense. Checking against the gold standard, so to speak.
Right. And importantly, they also checked for self-consistency. How consistent were these LLMs when judging the same piece of content multiple times?
Okay, so making sure they're not just giving random answers.
Precisely. Consistency is key if you're going to trust these models to be making important decisions.
All right, drum roll, please. What were the big takeaways? What did they find?
Well, some of the results were pretty surprising. That apology artifact, for example, it was a huge factor in the tie detection test. Most of the LLM judges were way more likely to favor the version that started with an apology.
Like significantly more likely.
Oh, yeah. Some cases, the apology version had a win rate as high as 98%.
Wow. So just saying sorry basically makes you safe in the eyes of some of these models.
Pretty much. It really highlights how these LLMs might be latching onto the form rather than the substance, mistaking an apology for actual safety.
Fascinating. Any exceptions to that trend?
Yeah, actually, Command R was interesting. It seemed to dislike apologies.
Huh. Went the other way.
Yeah.
Okay, what about the other artifacts?
Well, position was another big one. In the model win rate shift test, it caused some pretty big shifts, from 4% to 30%, depending on the model.
Meaning some models just consistently favored whichever response they saw first.
Or second, yeah. Shows how even something as arbitrary as the order you see things in can influence these judges.
So presentation matters, even for AI.
Apparently so.
Oh.
Now, the authority artifact, the fake citation, that one was a mixed bag. About half the judges seemed to actually dislike it. So maybe a bit of good news there.
Interesting. So adding bogus sources might backfire?
Potentially, yeah. Now, verbosity, the long-windedness that was surprisingly less impactful. Minimal effect in the win rate shift test, and often actually disfavored in the tie detection.
That's counterintuitive. I would have thought LLMs would love a good wall of text.
It's a common assumption, right?
Yeah.
But it seems like when you control for the actual content, they're not necessarily swayed by length alone.
Okay, so maybe they're getting a bit more sophisticated. What about the halo effect, the friendly ending?
That one didn't seem to move the needle much for most judges.
So no points for being nice.
Not in this case, apparently.
Okay, so it sounds like apologies and position are the big red flags here. And one thing I found really interesting in the paper was how they looked at whether better agreement with human ratings meant more robustness to these artifacts.
Yes. That's a crucial point. And what they found was that just because an LLM agrees with human judgments overall doesn't mean it's immune to these little tricks.
So an LLM could ace the standard test, but still be fooled by an apology or the order things are presented in.
Exactly. Shows that we need to look beyond just those top-level agreement scores when we're evaluating these models.
Dig a little deeper.
Yeah, we need to be more sophisticated in how we assess robustness. Can't just assume that alignment with humans equals true understanding.
That's a great point for the research community. Now, what about those other factors they looked at, like self-consistency and model size? What did they find there?
Well, the self-consistency stuff was kind of unexpected. Some models, even some of the really big ones like Llama 370B and the GPT-4s, showed some inconsistency when judging the same content multiple times.
Meaning they'd give a different safety rating the second time around?
Yeah. Not a huge percentage, like 3 to almost 6% of cases, but still, it raises some questions.
Yeah, if you can't rely on the same model to give you the same answer twice, that's a problem.
Definitely something to be aware of. And then model size, well, it was interesting. The bigger models did generally agree more with humans, but there wasn't a clear link between size and robustness to artifacts.
So bigger isn't always better in this case.
Yeah, sometimes those smaller models actually held up better against certain artifacts. So it's not just about scaling up, it's about understanding these subtle biases and finding ways to mitigate them.
Makes sense. Now, they also explored using juries of LLM judges, right? To see if that could improve things.
Yeah, that was an interesting part of the paper. They figured maybe if you combine multiple LLMs, you can get a more robust evaluation. Kind of like getting a second opinion.
So instead of one judge, you have a whole panel.
Exactly. They tried 3 different jury setups. A large jury with all the big models, a small jury with the smaller ones, and then a strong jury.
Okay, what made the strong jury special?
This one was carefully chosen. They pick models that not only performed well individually, but also seemed to have opposing biases. The idea was to balance things out. So if one model was prone to, say, the apology bias, another one would hopefully counteract it.
So kind of like checks and balances.
Exactly. And it actually worked pretty well. The strong jury showed the best improvement in both robustness and agreement with humans.
So some promising results there, but did it completely solve the problem?
Unfortunately, no. Even with this carefully chosen jury, they were still somewhat sensitive to artifacts.
So it's a step in the right direction, but more work to be done.
Definitely. This is an area that needs a lot more research.
For sure. Now, before we get to our Novel Nations segment, I want to zoom out a bit. Why have we been moving towards this LLM as a judge approach in the first place? What's the historical context here?
It really boils down to scalability. As LLMs become more capable, the sheer volume of content they generate is just overwhelming for humans to evaluate.
Right, it's like drinking from a fire hose.
Exactly. And especially for safety, where we want to catch problems quickly, human evaluation just can't keep up. So the idea of using LLMs to judge other LLMs emerged as a way to automate that process.
And had there been any hints of these kinds of biases in LLM judges before this paper?
Oh yeah, definitely. There's been work on things like position bias, where the model favors the first or last thing it sees, and verbosity bias, where it prefers longer responses.
Makes sense. Those seem pretty intuitive.
Yeah, and there's also been work on self-enhancement bias, where a model might be inclined to rate its own output as better.
So this paper isn't the first to point out biases, but it seems like it's really digging deeper into those safety-specific artifacts.
Exactly. It's systematically testing these artifacts across a wide range of current models, and it's challenging that assumption that bigger models are automatically better judges.
Right, it's more nuanced than that. We need to be smarter about how we're evaluating these models and how we're building them.
Absolutely. This paper is a great example of the kind of critical research we need to be doing.
Okay, so let's move into our Novel Notions segment. Based on this paper, what are some potential future research directions that you think are worth exploring?
Well, one thing that jumped out at me is the idea of artifact-aware fine-tuning. So imagine creating a special data set specifically designed to help LLMs unlearn these biases.
So you'd train the model to recognize and ignore those superficial cues.
Exactly. You'd show it pairs of completions where the safety level's the same, but one has an artifact and the other doesn't.
Interesting. So it would learn that an apology doesn't necessarily mean something is safer.
Right. It would start to focus on the actual content rather than getting distracted by these surface-level features.
That makes a lot of sense. And how does this differ from the way LLMs are typically fine-tuned for safety?
Well, a lot of current methods focus on aligning the LLM's judgments with human preferences. But as this paper showed, those human data sets might already have those same biases baked in.
Right, so the LLM might just be learning those biases from the humans.
Exactly. So this artifact-aware fine-tuning would be more about teaching the LLM to recognize and disregard those biases.
It's like giving it a more critical lens, helping it to see past the surface.
Yeah, I like that analogy. And if we can do that successfully, I think it could have a huge impact on the safety and reliability of LLMs in the future.
That's a really interesting direction for future research. And it really speaks to the importance of this paper. It's not just pointing out problems, it's also giving us a roadmap for potential solutions.
Absolutely. This is a paper that should be on everyone's reading list.
Agreed. It's a great example of the kind of rigorous, thoughtful research that's pushing our field forward.
And a good reminder that we need to be constantly questioning our assumptions, especially as we're building these increasingly powerful systems.
Couldn't have said it better myself. So for all of you listening, if you're working on LLMs or even just following the field, I highly encourage you to check out this paper. We'll include a link in the show notes.
And in the meantime, keep those tensors talking.
Until next time.